I will tell you a little bit about myself, what got me to where I am today, and I'll tell you about the aquaculture going on at the Long Island Aquarium, which is by Reef, my company. We'll talk about coral and invertebrates out of water naturally, and then the shipping experiments that I conducted as a result of all the things above. So I've been a passionate aquarist, much like you guys, my whole life. First pet was a fish, and after I graduated high school, I started working in retail at Dolphin Pet Village, which got me kicked into the marine field pretty quickly. I worked at a Steinhardt Aquarium, which cemented my understanding that I was going to be in marine biology as a career for the rest of my life. That's the 200,000-gallon aquarium reef tank at the Steinhardt in the lower left-hand corner, which I can point to, thanks to the pointer. And then after Steinhardt, I moved up to Bellingham, Washington to get my marine biology degree at Western Washington University. They have a great marine program out there on Whidbey Island. So while I was in school for marine biology, I thought, taking a full course load isn't fulfilling enough, so I started a reef shop called the Chronic Reefer, forgive the name. It came with my partner before I got there. It does correlate with Bellingham's alternative activities, but not with anything going on in the shop. There was a lot of confusion with the name of our shop and the bright halides in the window. We had a lot of people come in that I called U-turns. They would walk in with a smile on their face, and they'd go to the back and they'd get quieter and more frightened until they made a U-turn. And on their way out, if they could bear it, they would turn over and they'd go, "What is this place? Aquarium? What's happening?" And then if they really made an effort, they'd try to see if we could do anything for them, like sell them, and we couldn't. We're way out of that price range. So, the Chronic Reefer was a great shop. We had lots of coral frags. It was small. It was next to Ryan Styles Improv Theater. And when I graduated college, I left the Chronic Reefer to pursue manufacturing. So I went from working retail to owning a retail shop to working in the manufacturing field for aquariums, and that was mainly lighting. I worked at IceCap and ACAM Lighting. That's a booth I did at Magna a few years ago, and that got me into the wholesale side of things, which is a wonderful area of the aquarium industry to work in. If you guys haven't tried it. And during that, I actually moved out to the East Coast. Thanks to this slug flying around with turtles and talking about how great the East Coast is. And I started working on shipping experiments and other little coral experiments because my passion as a scientist, as a marine biologist, wanted to continue despite my need for a career. So this is a little shot of my old reef tank, some frags that I always kept going. There's that guy again. And this is what we're doing now. So Justin Incredible from LA has moved out to Long Island, and he and I co-own a company that we started called Reef, which does aquaculture, coral, and fish. It's based out of the Long Island Aquarium, and it's fantastic. It's a wholesale aquaculture company, so we only sell at the wholesale level. We're in partnership with the Long Island Aquarium, who supports us with a great tank space, and we help maximize their livestock and captive breeding collections. We focus on local and sustainable aquaculture, captive grown coral and fish. We consider ourselves a green alternative to wild collected coral and fish, but that's not to say that we shun wild collected coral and fish. Without that, we wouldn't have any aquaculture coral, and it's great to keep the livestock fresh. We sell to public aquariums, coral researchers, and mostly brick and mortar stores around the country, e-tailers, some aquarium service companies, and online retailers as well. Just by the way, locally we sell to Manhattan Aquariums. They always keep a great supply of our inventory. And Aquarium Village, an amazing shop as well, and Caribbean Blue. So who is Reef Jen? This is the hairy guy on the left. That's just incredible. I'm not sure if he's spoken here before. He's a good speaker. He lives out in Hampton Bays, and he's the co-founder. That's me, and there's Joe. He's what I call the eye candy and the sun maintainer of the company. I'm not sure what he does, but he also happens to be the curator and co-founder of the Long Island Aquarium. And that's Todd Gardner. I know he's spoken here before. He is a world-renowned marine fish trainer, and he's had incredible accomplishments. He works for the aquarium, but he also sells clownfish through Reef Jen and some other things I'll show you later. And that's Tracy Morgan. We are at his house in this picture, and he called us out there because he needed a home for his shark originally. So Joe and I helped wrestle his nurse shark to a better location. And then, what's that? Yes. Yeah, but that's not the tank that we visited at the time. That tank is a great tank called Lactose. So it's a good shark. I should probably say, normally it's not the policy for the aquarium to take any livestock from end users, customers, because it encourages the ownership of unsustainable species, but this was a special exception for a number of reasons. If Joe would care to comment. He would not. Okay. So we're at his house in this picture because he got a bunch of Reef Jen coral, which led to a couple corals named after him. He's a passionate reefer, including the Gorgonian called the Tracy Morgonian and the Tracy Donnie Morgan. So this is the 20,000-gallon reef tank that inspired the company. That's Joe's tank out at the Long Island Aquarium. This was back in 2003 or so. And here it is now, packed full of coral. Huge colonies now fill the tank. And he has so much that when he does prunings, he's a place to put it. So we help culture it to a larger source. Here's a picture of the 6-foot yellow turbonaria on the left. This is a 12-year-old colony, completely captive grown, a lot of fish. And this is the right side of the tank. This is actually a dim picture, not really representative of what it looks like. This sort of looks like a stark dichotomy. But really this side of the tank is just as beautiful, filled with beautiful acroporas, styloporas, and other things. So what it has produced is 20,000 gallons of mother corals from an aquaculturist perspective. This is a 20-inch acropora called the Green Titan, Joe named it. And a lot of beautiful gorgonians that can be sustainably cultured into a source for hobbies. So I thought I'd give you a little peek at what it's like above the tank. This is where I spend the majority of my day, and we've tucked little aquaculture tanks into various nooks and crannies above Joe's reef.
I lost my man cave, just for the record. My man cave is gone.
Yep, and it's much more organized and clean.
Joe, is she walking
They know
tonight?
me for 20-something years.
You were CEO, forget about it.
I thought I'd give you a quick 360 spin in the tank to give you an idea of the magnitude of coral in this tank. There's that giant turbonaria, huge stylophora, the green stylophora back there, an entire boulder colony covered in magnifica anemones, gorgonians that are literally that big.
23 years old.
23 years old. So it's an impressive collection. And give you a little overview of what the aquaculture is like at the aquarium. It's pretty simple. We take mother colonies out of Joe's reef, and Joe often hands it up to us. That's a picture of me having a rare plunge in. I was not allowed to collect on that trip, but I look forward to it in the future. And by mother colonies, what we collect from Joe's tank is actually pieces that are surprisingly small to start the cultures. It's usually, I would say, 6-inch frags at most, sometimes smaller. And then we have to nurture and divide them until they grow into enough to provide many frags, like you see here. This is the purple Milka stylophora. Those are some frags in development, and then we ship it out after we frag and grow up. So this is the area of Joe's tank formerly known as this man cave. This is now the wet table and wet thaw that we use in order to propagate the coral as stingpie plums. Very proud of my wet table, I built that. And some very large propagation tanks holding mother colonies in the back. And I wanted to show you what it's like fragging Milka to give you an idea of coral propagation. There we go. So this is beginning with looking through our broodstock. This is now the mother colonies. Joe gave me one of these colonies to begin with a year ago, and now we have racks full of it. We sell large colonies to aquarium service companies and smaller colonies to retailers for hobbyists. So I pick out of these a nice branching colony, pry it off the egg crate where it's grown onto. This one's about 5 inches when we begin with it. I set up my saw, have some plugs soaking so they don't get bubbly with the super glue, place to put the new frags, and then get some protection on. I steal Joe's super glue, I put on a glove, you do a little encouraging dance, and then you're ready to go. So, part of Joe's job at Reef Gen is to maintain the sump, which is that large tank below me, provides wonderful water and beautiful colors for the corals. The water also, I thought I heard some fizzles. Hello? The water coming out of the saw is also reef water. That helps to keep the coral cool during the cutting process and also rinses away the mucus and the toxins that it produces in defense of a large mechanical object. So the trick to fragging is to try to wiggle the colony into place on that saw where you don't cut 8 other branches at the same time. And at the same time, you also get a nice perpendicular cut on the branch so the frag stands up straight, and you find an attractive branch tip. And then once you do a couple cuts, you get really good at it, so you go really fast.
Drinks a lot of Red Bull.
Drink a lot of Red Bull, a lot of coffee. And it's like a 5-minute fragging process to cut that 5-inch colony. No, it really takes about an hour to go through a colony carefully. Stylophora is one of the harder things to culture, not because it's sensitive, but because it is a massive coral. It's a thick branching coral, which means it grows very slowly and it encrusts even slower, if at all. I have some frags that are 6 months old and have no tissue around the bottom. Most of them encrust, but it takes a long time. Here's that process. I use icy gel glue. It is amazing. I recommend it to everybody. There's 2 techniques for gluing a frag. That's the teeny tiny drop of glue technique, where you end up with a frag that is not covered in super glue. But that's if you are working on presentation, you're more careful about that sort of thing. Another technique is to use a huge amount of super glue, which is commonly done, and that way you get cold. Should I stop using this? Is this distracting?
Hold it closer.
Okay. Hold it closer. This looks better. Okay. If you use a lot of super glue, it will squish up around the branch of the coral, and when it dries, it provides a mechanical lock. When you use the teeny tiny drop, you have to put that coral in a low flow area and be very, very careful with it until encrust, which can take a long time.
What actually are you gluing it to?
These are small ceramic frag plugs. This brand is made by Alternative Reef, and a lot of different companies make these ceramic plugs, but they're all designed to fit neatly in a crate. The rack that I'm putting them into is a modular system developed for our aquaculture tanks, where we can switch racks from tank to tank. So again, more coffee, you finish quickly. And here we have that mother colony, and it's only been trimmed down to a 4-inch colony and produced 32 half-inch frags. So shave an inch off of a delicately branched coral and you get a lot of frags. This is Joe's tank. Reef Gen supports Long Island Aquarium by growing coral to repopulate their displays. It has nothing to do with Joe's talents or abilities. This is a bunch of mocha that Joe stole from us and used to replant part of his reef. And that is the colony that he took it from 6 weeks ago. So, like I said, it's a pretty slow growing coral, but you can see those tips are fully polyped out. Milka. So that's the milka presentation. Here's a glimpse into the coral trough. We have a lot of high-end LPS growing. Each one takes different conditions, different lighting, different flow. This is a beautiful chalice that we have called the Sioux Scramble, because it's like green eggs and ham. You can see you make frags of different sizes based on the rate that they sell. Alien Pox. So this is our super high-end tank of some of our most precious stuff that really doesn't grow that fast, and we have a limited quantity of. The green litho is actually one of Joe's legacy frags. He has colonies of that in his aquarium. He does very well with it. Then here's another glimpse into a coral propagation tank. These are a mixture of LPS and SPS, so that was Goniacora. These are different brain corals, Favias, war coral, Echinata, yellow parites, Seriatopora, bird's nest, Stylopora. I hope you guys know your coral names, otherwise this is all meaningless. Acro. I could go on, but again, the key is having each one in the correct location for the right light level, the right flow level, and the compatibility between the different coral types. Those are some mother colonies. And using your space wisely. So it's a lot of fun working out of the Long Island Aquarium, where we've built a lot of systems to grow the coral, and we're constantly working on new varieties to expand the selection. And coral's something I'm passionate about. Regardless, it's like a kid in a candy shop every day.
Question.
Yeah.
In a system like that, the way you have it structured so kind of widespread, how do you feed that system?
Feed the coral?
Yeah, that massive.
Well, we actually have a lot of pipettes, believe it or not. We use coral food, and we use cyclopes. We use two little fishes, Goni Power. It's like that powder. But we don't have to feed the corals every day. We just do it a couple times a week. And mice for the acants, that sort of thing, and then great light and flow. And the nutrition comes from the coral itself. Yeah?
Question about the shell of life. Over the years, on our table, we have some coral colonies. And exploration days, I know it's 1 week. It's still be good.
Probably. I've never worked in coral food manufacturing, so I can't speak with great authority on this. An old fish guru once told me that if the food doesn't smell bad, then it's gone bad. So I don't know. It probably just loses its nutrition value. The vitamins decay to something less useful, is what I would imagine. So some aquaculture varieties of coral fish that come out of the aquarium include these. So these are corals that Joe has been growing for a very long time in his tank. The stylos, the top middle one is the orchid stylo with the pink tips, and that is up for the raffle. The coral to the left of it is the purple stylo, that's also in the raffle. Oh, and is the plating turbonaria. So
You mean the auction?
auction, yeah.
That's okay, we all understand.
Okay. Yeah, thank you. Yes, the option. So those are labeled, and I'll have pictures of them later on too. These are some of those higher end LPS again, the alien blocks, the mind blower. And these LPS, you know, some of them grow surprisingly quickly, or well enough that they can be aquacultured in a relatively feasible period of time. And then the softies, of course. See, again, this is Joe's 23-year-old photosynthetic Oregonian. This is also a variant. This is probably a 10-year-old Simularia called the Scheimer Simularia. You guys may remember Greg Scheimer. Joe has enormous colonies in his tank, but this thing is impossible to culture. So we release it in limited quantities. And then we have the fish breeding. These algae tubes, of course, are Todd Gardner's algae tubes at the aquarium. He spends a lot of time culturing copepods, rotifers, and different breeds of algae to feed them all to raise fish. So these are, of course, his beautiful clownfish. A mono. He raised monos, a bunch of monos from Joe's tank, catching. Joe caught the larva of these monos with a big plankton net, and then Todd raised them with his magic pouch. Here's some of the fish in action. These are some of Todd's baby Long Island Reds, we call them. Great little Ocellaris. Even though there's a weird camera in their tank that they've never seen before, they're still attacking my fingers up in this corner. And then this is our friendliest fish. The neon gobies, these are also captive bred. They love to snuggle. No, they're a cleaner fish, and they will pounce on anything that enters their tank with that instinct to look for parasites and funguses and misplaced cuticles. Todd's also a master breeder of seahorses. He actually got his, literally, he got his master's in seahorse something or other. There we go. Husbandry. And these are either red or erectus, which I guess doesn't help you much, but these are the ones that turn bright yellow. And then this is a cutie. This is actually an oyster toadfish bred by a great aquarist at the aquarium called Rachel. Yeah,
a little.
Yeah. And then the aquarium also breeds sharks there. They have an 80,000-gallon outdoor tank filled with sharks and rays and other tropical fish. And the bamboo sharks will breed in there. They also have a cold water shark, a rare cold water shark breeding called the chain dog. And then my favorite are the cuttlefish. These are what I've been working on. I got eggs back in October, and we hatched out the top two adults there. You can see they have a lot of personality. The one on the left was puffing at me. You can see the color change with the one on the right, and their ability to change patterns in terms of spots and intensity of coloration is just infinite. The one with the two spots on his back will turn to that mottled color in a heartbeat if he wants to, but that was his personality, was to flash his eye spots at me whenever I came over the tank. These babies laid eggs, and then they had babies themselves. I'm proud to say I'm an official cuttlefish breeder. This is a baby, it's 3/8 of an inch. This is sewing plastic right here. And there's more. This is the best part of the cuttlefish, is feeding them. You can see them flashing with excitement. They eat shore shrimp, and they feed by shooting out those, you see that white dart? Those are actually two modified feeding tentacles with a sticky pad at the end. And they shoot it out like an arrow, and right before it gets to the shrimp, it spreads out, grabs the shrimp. Here's another one you can see. And in this one, you can actually see those feeding tentacles separate. It's in a blur, because it's so fast, this is slowed down to something like 5 times slower than the normal speed. That's why it takes a second. But you'll see from the top, there come the feeding tentacles with that little dart tip. And you can see them kind of separate a little bit for that instant. And every time, even as babies, every time they get a shrimp, they hit it right in the middle of the back, because that way they can pull it in and the legs of the shrimp are struggling away from it so it doesn't get injured. Reminds me of the kraken though, with those tentacles. And here are the babies. This is the babies at 2 weeks old. That's my thumbnail to give you size reference. And the one on the bottom is going to turn around and get a mysis shrimp in the top. That mysis shrimp is equally tiny, but for two tiny things, it's a mammoth. They're able to eat shrimp that are over their body length, but you see them get knocked over with the size of this project there. Pretty cute, right? So hopefully we can get enough of those going that we can offer them up for aquarists and retailers as well. So, all this talk about shrimp. Let's get back to the shipping. One of the things that inspired the shipping experiments was working as a retailer and in the wholesale division. You get shipments of shrimp and snails and they'll die in shipping, and you wonder, was it the shipping method? Was it something that happened during shipping? And the consequences is not only just a dead animal, but for turbo snails, I don't know if you've ever experienced this, but a bag of dead turbo snails is a fate worse than death in terms of smell. Like, it will permeate that room in a heartbeat and stink for hours and hours. And then you'll smell it for days. So, looking into it, I started looking at peer-reviewed papers of dry shipping, and the research out there for dry shipping is actually centered around the food industry. So lobsters and spot prawns were the only animals that I had any information on dry shipping. And believe it or not, lobsters and spot prawns, their preferred method of shipping is dry. These spot prawns, the Panay shrimp in the lower right, the best way to ship them is in chilled moist sawdust. This is a marine shrimp. Another method that they use is alone in a moist bag, both of which use oxygen. They found that the one thing that really does affect mortality rates in dry shipping is not the fact that there's no water, it's that you need to let the animal rest after capture, which is a bigger deal for wild collected shrimp or even aquaculture shrimp. At the level that they're doing when you do a big capture, it might as well be wild collected. So looking at that research, I started looking at low tides in nature and papers on coral reefs. And there's a large degree of variation in how much corals actually experience being out of water. You would think that they're never out of water, but in fact, in several areas, like you can see in this picture on the right, corals are regularly exposed at low tides. It's possible that the region may have no corals exposed at low tide, but some will be exposed twice a day. Some will be exposed only during the extreme exposure tides, a couple times a month. Or, like our friend did, he built a tank that was designed to expose corals for 6 hours daily. The trends for these corals is that they're robust shaped, and by robust it means that they're sturdy, they're conical, or they're mounding or tabling. They also include some LPS like bouldering grains, aphabias, platygyros, that sort of thing. Those are all the corals that tend to be out of water. It's easy to remember because they're in a surge zone, so anything that you think can withstand waves likely is also to be built to be exposed to air. Chris Moffin wrote a great article in Reef's magazine about low tides. Or rather, it wasn't so much about low tides, it was about the fact that the seabed was rising. And the coastal area was actually being raised out of the water 1 to 3 millimeters per year, which caused everything on that substrate, everything on those rocks to be raised up too. So corals that have been growing there for a couple decades these colonies were becoming more and more accustomed to be out of water. So there was a lot of acroporas that were routinely exposed in this unique area. Again, these corals included those robust shaped corals, the humulus, the gemifera. These are all the conical, sturdy shaped corals. And they also table too. Hawaii also did some research on coral. They found, what was interesting about their research is that they found that it was actually the desiccation that killed the coral, not the heat. You know, some people think that it's when they're exposed out of water, the temperature variation without the buffer, the heat sink of water, is what kills them, but it's really the, according to the Hawaiian research, it's the dryness, the desiccation. And the way they determined that is that they worked on the cellular susceptibility of Polypora and Fungia in terms of their heat sensitivity. And when they determined that they were heat tolerant and they still died out of water, it was because of the desiccation. So, interesting stuff. This is an English aquarist who built a tank based with a plunger system that would twice a day drop the water level to about 20% lower than the normal level, and it would expose all the coral above that for about 3 hours a day. And he was playing around with different species, and so he had some experience with exposing corals to air. His theory was that mucus was the thing that saved these corals, that made them more adept at surviving being out of water. These are the corals that he found to be hardier when being out of water. They include some of the things we talked about, the sturdier acroporas, and some surprising things. He found that pipe organ was a hardy coral out of water. Zoanthids are commonly shipped without water from tropical countries. So that's not a surprise. Leathers are often shipped without water, so the toadstool's not a surprise, but pipe organ was pretty interesting. Echinata was interesting because that's a very delicate branching acropora up here. And he found that there were certain corals that did not do well being exposed, which included deep water corals and these thinner branching corals. Interestingly enough, these are the ones I tested. So we have low tides all the time in our tanks too when we do water changes. This is Joe's tank with a water change. This is a 2,000-gallon water change that he does a couple times a month, maybe 3 times a month, and exposes his acroporas. So we see that our corals don't all die when they're out of water. But the importance of this is there are so many points of transit when between the point of collection and when they get to our tanks. There's so much stress each time that they're transported. We need to find a way to reduce the mortality as much as possible. And that's where I found the research on dry shipping. So typical shipping practices for invertebrates, including shrimp, snails, and coral. The most common method, as you guys know, is 1/4 to 1/3 water and 3/4 oxygen in a plastic bag. Another method that I think is used more often in the freshwater community are these breather bags. We don't see them as much in the marine community, but it's another good technique where you can do 100% water. Dry shipping is actually not blotted dry. It's not no water whatsoever. It's moisture. You can see drops of water here. Sometimes there's a puddle in the bottom. Or in the case of the spot prawns, they use the chilled sawdust with saltwater moisture packed in too. But both always have oxygen. Oxygen's key. The importance of this again is, not just if you lose your animal, there's a financial cost. There's a financial cost of replacing animals lost during shipping. And there's the cost of the weight of water. When you ship water, it's incredibly heavy. It can be, a couple $100s to send a box of coral or fish across the country loaded full of water. If we can reduce the weight, it's a good chance we can reduce the cost of the shipping. Ecological, of course, this is more of an ethical thing, like you don't want to kill animals, but also, if you kill more animals in shipping, more fish and coral, then, you're going to have to collect more from the wild because there's still that demand in people's tanks. So here's what I was thinking. I wanted to know which coral invertebrates survive dry shipping. Does shipping duration, the length of the shipping, affect dry and wet shipped organisms differently? And which species preferred wet versus dry shipping? Pretty straightforward. This is a beautiful Diploastria in Fiji. So I put mollusks because the stench of dead turbo snails was still burning in my nose from years ago, and I wanted to solve that question. So I tested what shipping methods with turbo snails, astrias. These are all very common marine snails. This is a burrowing snail, the Sarah and the Necarius. And then these are little intertidal snails, so I thought that'd be interesting. I did not test tridacna, very expensive, so impractical test subjects. So with the coral, what we tested were coral that were readily available from the aquarium, which included Monty caps, those big platy corals, blue tip acros, and the millies. For the crustaceans, I was originally just going to test snails and coral, but after reading the research on spot crabs and lobsters, I got excited about testing peppermint shrimp, which had never been done before, and hermit crabs for the hell of it. So I first did this experiment back in 2009 with my experience in biometrics and marine physiology. I kept the testing parameters rigorous with randomization and replicates, proper number of treatments and statistical analysis. I checked for arrival. I checked for the on-arrival death rate, which is the DOA. I labeled all the organisms to keep track of them and see what their death rate was after arrival too. So the methods used tested short versus long shipping, which was 12 versus 36 hours shipping, and wet versus dry, which produced 4 different treatments. And this was done with 60 different individuals of snails. The wet method was wrapped in wet paper towels, which was common with my local wholesaler, and then the normal wet method. With crustaceans, I did the same shipping methods as with the snails. I did 24 versus 36 hours and the same treatments with 20 individuals. So the results were, on arrival, they did pretty good. The turbos and the astrias, I lost very few on arrival with all the different treatments of long and wet and short and dry and long and dry. Shrimp, I had more mortalities with dry shipping, but on arrival, I had much different results than after tracking these snails and shrimp over the next few days. So here are the mortality results after 4 days of observation. Now, you can see that the mortality goes up significantly from those happy green 0% mortalities on the previous graph. But here's the tank of the test experiments after those 4 days. So there could have been sort of a cascading effect of you have a couple dead snails and everything tanks. Oh, thank you so much. I am choking with dry throat.
The dry talking method.
The dry talking.
There you go.
Should I show more videos? What? Give me graphs. Graphs. Okay. So the mortality rates went up, but what my professor talked to me about was that these error bars, which shows you the strength of the results, were enormous, which means that this looks very different, but statistically is not different because the error bars are so big. And that was true for the majority of them. The error bars had a lot of overlap. The trends that I took from this, even though the error bars were so big, was that because survival rates were so good on arrival for hermit crabs and turbo snails, in dry shipping and wet shipping, I thought a conclusion was to ship dry with those two, because they fared well. The astrias fared very poorly throughout, so ship wet to protect them, but there may have been a pollution effect. And then the shrimp, we have no idea what the results were with that first experiment because there were a few replicates and the results were all over the place. So I wanted to improve the experiment. I went from a small polluted tank to observe the arrivals to a 600-gallon well-filtered reef. I wondered about the paper towels suffocating them, so I got rid of them in the new experiment. I wondered about packing density interactions, so I packed in singles. And I wondered if the durations were too long for shipping, so I shortened the durations. This is that same Diplobastria I showed you in the Fiji picture, and this is the line of death that we found in the wild. It was interesting and fitting for the graph. So we did a couple pilot tests to see what method worked best, but it was difficult to figure out what method was a good one to test for. And we decided to test 3 different methods. I was very nervous about the shrimp because so many shrimp died in the last experiment. So I did short durations. I only did 12 hours. And for the dry treatment, I did a wet piece of filter floss to keep the bag moist with the shrimp. I did a puddle method, which is about a 1/2 inch of water. And then I did the normal shipping method. And I did more shrimp to see what the results were, 30 shrimp. For the snails, we did the same methods as before, except we mixed the paper towel, same types of treatments, and a lot more snails. And here's how we tracked the results. We put one of each species in these containers that were labeled so we can keep track of who came from what treatment, what wet, dry, long, short, whatever. And here they are pictured again. And here are the results of shrimp after 12 hours with no water. This was very exciting, so I filmed it. Are you excited?
Yeah.
Yeah, there you go. He's moving! He's alive! And not only was he alive, everybody was alive. So this is great! 530 specimens survived all the different treatments. It does look like a turtle. Is there a turtle? No. That's a turbo snail and a Neurites snail by the top of it. That makes it look like a turtle. So everything survived, which was really, really good news in terms of we found a bunch of great ways to ship things. It was really bad news as a scientist to find any differences in the methods. So we had to tweak some stuff because this is not great data from a scientist's perspective. From the animal lovers, it's terrific. So with the shrimp, I pushed the limits a little bit more, and I stretched out the duration. I did 24 hours with the same methods of dry, puddle, and wet. And I did 81 shrimp because I got confident. So it was 9 replicates, and I did 27 shrimp per treatment with those methods. And we have mortalities, yay! No, it was terrible. But the survivors actually had no DAAs, they had no death after arrival, which meant that the data was pretty clean. And we found out with the mortalities, those shrimp were pregnant. So there was some sort of correlation between pregnancy and sensitivity to shipping. But here's the data, it's still interesting. So these lines represent the 3 different shipping methods for 24 hours for shrimp. The green line is the average of mortalities for the dry shipping, so that had the most mortalities at 40%. The blue line represents the wet method, that's the second most mortalities, which is the normal shipping method. And interestingly, that red line on the bottom is the puddle method with a 1/2 inch of water, which only had 1 mortality in 27 shrimp. So that was very interesting, that the puddle method was the most successful way to ship peppermint shrimp. And here's that data again across the shrimp. You can see that the puddle has the lowest mortality, and the dry has the highest mortality, but only in the longer duration. So shrimp conclusions, puddle is the safest way to go. Go with a very small amount of water and oxygen. In the shorter shipping period, all the methods work really well. But in the 24-hour, you want to do a little bit of water. The dry was not as successful. So shrimp I painted on my niece's wall. Thank you. So the coral that we shipped, we tested with similar to the snail methods. We did the same treatments with duration and wet dry. We did no water in the bag, no paper towel, just drops of water, and then the normal water method for the wet. And we did 12 versus 24 hours with 40 frags per species of coral. Here's the observations. We had mortalities in the longer shipping periods, and we had mortalities, the most mortalities was in the wet shipping. So this is that millipore, that rose-colored coral. This is the plating coral, and this is the blue-tip acropora. So the long wet shipment, this is still not many mortalities across the board for 12 and 24-hour shipping. My caveat to this is I wonder if the long wet shipping would have had more mortalities based on the health of the coral long term. Because in this treatment with the long wet shipping of the millipora, these guys are big question marks. So this number could have gone up quite a bit over the next couple of weeks, we're not sure. Because shipment expect. Okay. So these are the trends again. Long wet shipping had the highest mortalities for all the coral, and the long dry shipping had a couple for the millipora, so it didn't fare well. But I wonder if that should have gone up. Conclusions, the long wet had the most mortalities, suggesting that maybe we should look at dry shipping for more corals across the board, but all of them did really well with the methods. Future experiments, more coral, more replicates, add temperature fluctuations, shake the box, all that good stuff, and oxygen versus air. So thank you. These people were all very helpful. Not so much the top guy, but the rest were great.